Today we will start with potential energy. Earlier we have discussed about kinetic energy and we have said that energy by the virtue of motion is kinetic energy. Now if the object is at rest, then also it has the ability to do work. It implies that in the state of rest also a substance or a material is having some amount of energy. So the energy by the virtue of its position or shape is considered as potential energy. So now we will define potential energy as energy due to virtue of its position or shape or configuration is called potential energy. We can take example of water that is stored in dam has potential energy due to its position. Now we have two types of potential energies. First is gravitational potential energy. So now we will discuss about gravitational potential energy. When any substance or any material is at some height above the surface of earth and it is at rest, then it must be having some amount of energy. That energy is known as gravitational potential energy. So we can define it as the energy possessed by a body by the virtue of its position. We are taking position because it is potential energy. Okay, and it is at some height above the surface of earth. Now we will determine the expression of potential energy of a body at certain height. For its expression, let us consider a block of mass m, which is raised to some height h. The force must be required to lift the block, that is equal to the gravitational force, and gravitational force is equal to the weight. So F will be equal to mass of the block into g, that is acceleration due to gravity. Now the applied force on the block, that is mg, will raise this block of mass m to height h. So h is height by which the block is raised. So in this case we have force and the displacement of the body of when this force is applied on the body. So now we will calculate the work done. as we have discussed that work done is equal to force into displacement, that is D. Here F is equal to mg, that is weight, and displacement is h, that is height. So work done is mgh. Hence work done by applied force F is mgh. When the block is raised to some height h, then some work has to be done by the gravitational force on the block. So now we will calculate the work done by the gravitational force when the block is raising to some height h. In this case also, work done is force into displacement. Here force remains the same as body is same. So F is mg. But displacement D is h cos 180 degree, and cos 180 degree is equal to minus 1. So work done is equal to mg into minus h. So total work done by the gravitational force on the block is minus mgh, and work done against the gravitational force on the block is known as gravitational potential energy. Now we have calculated work done by gravitational force, that is minus mgh. Some work is done against this force, so that will be equal to minus mgh, that is mgh. This is the work done against the gravitational force on the block, and this work is said to be gravitational potential energy. So expression for gravitational potential energy is product of mass of the body, acceleration due to gravity, and height up to which a body is raised. Now we will discuss about second type of potential energy, that is elastic potential energy. Potential energy, as we know, is an energy by virtue of position, and word elastic means if we compress or stretch anything and it retains its original position, then it is known as the elastic. So the energy of a body by virtue of its deformed shape means the shape which is not in its proper position. Either it may be stretched or compressed. So in that case, the energy possessed by that body is known as the elastic potential energy. Now we will discuss some important points regarding this potential energy. In gravitational potential energy, we have determined its expression, that is equal to mgh. According to this expression, potential energy depends on height. So, we can say that it does not depend upon the initial and the final position of the body. Means gravitational potential energy is independent of the path followed by the body. It only depends upon the path. It is only depending upon the height, that is h. If we are taking some straight path or some curved path, it doesn't matter. The thing which matters in the potential energy is only the height. Next point, if we want to calculate this gravitational potential energy on the surface of Earth, then height, that is h, will be equal to 0. It implies that energy will be 0. So, at the surface of Earth, gravitational potential energy of a body is 0. And in this case, if the body is moving upwards, then h will increase, and increase in height will increase the energy. And if body is moving downward, then h decreases, which in turn decreases the potential energy. So by varying h, we can increase or decrease the value of gravitational potential energy. But we cannot change the energy by changing the path, because it does not depend upon the path which is followed by the body. These were the few important points about gravitational potential energy. As we know that energy is converted from one form to another. So now we will discuss the interconversion of potential energy and kinetic energy. In this topic, let us consider first case 1, which is for a freely falling body. If any body is falling freely, then it must be at some height. So let us consider that height be h. First, let a body of mass be m at height h from the surface of Earth. So at highest point, the potential energy of the body will be u, that is mass of the body, into acceleration due to gravity, into height, that is from surface of the Earth. This is the total potential energy of the body. Now we will calculate its kinetic energy. Kinetic energy is half m V square. But body is at rest. So if it is at rest, then the kinetic energy of the body will be 0. These two equations tell us about the kinetic and potential energy of the body when it is at height h. Now, if we will calculate these two energies at lowest point, we will note that its potential energy, that is mgh, will be 0 because h is equal to 0 as the body is now on the surface of earth, and on the surface of earth h is 0, so potential energy will be 0 and its kinetic energy is equal to half mv square. Now, by using third equation of motion, we can write v square minus u square is equal to 2gh. Here v square is the final velocity, u initial velocity, g acceleration due to gravity, and h is height from where the body is falling. So in this case we have considered that body was initially at rest. So v square will be equal to 2gh as u is equal to 0. Now putting this value of v square in the expression of kinetic energy, we will get mgh. Hence its final kinetic energy is mgh. This mgh final kinetic energy is equal to initial potential energy. Therefore, we can conclude that energy is conserved. Hence, we say that whenever we have a freely falling body, its potential energy is converted into kinetic energy, means there is simply the conversion of energy, but energy remains conserved in the whole process. Now we will discuss about the law of conservation of energy. Earlier, we have discussed that mass of a system remains conserved. It can neither be created nor destroyed. Same principle works for energy also. According to this principle, the total sum of energy of all kinds, means whenever we consider a system, there are many kinds of energy which are acting on that system. So, sum of total energies in an isolated system remains constant at all times. This statement simply means that energy can neither be created nor destroyed, but it is transferred from its one form to another. In this conversion also, the total amount remains constant.